Good evening, everyone. On behalf of agricultureinformation.com, I welcome Mr. P R Aravinda, and he will speak on the topic using ML to detect diseases in the field. And I request the speaker to begin. Thank you.
Thank you. Thank you for the introduction. Hi, everyone. First and foremost, more than looking at it like technology, what exactly are we trying to look at here? Agriculture, as you know, is one of the main things. It's like a backbone for our existence, irrespective of which country where you live in. Agriculture is the backbone. And what are the things that are having an impact on the outcome from an agriculture perspective? There are different aspects. Some may be related to the things like climate, others may be related to the seed, soil, and one of the major things is about diseases. At any given point of time, we may have followed the process properly in order to deal with all the things, but disease is something that is most of the time unpredictable. And as you all know, the major problem with dealing with diseases is it is always reactive in nature, which means the damage is done and then only we take a prevent the appropriate corrective action so that we'll be able to get the things in hand kind of a scenario. And again, here, one of the most important things is what exactly are the particular actions that we are taking. That is also important because first and foremost, for all the diseases, there is no generic steps that can be taken. For each kind of disease or each kind of the particular issue, the remediation steps are completely different. And many a time, the diseases may look quite similar, but they are not exactly the same. So there also you will need to understand and work with it. Now, normally how it is done is people who had experience, who have worked, who have seen this before, they can understand, they can do a differentiation, and based on that, it can work better. However, in that particular scenario, the scale, the understanding will not be possible across the board. For example, there are some X thousand farmers who are there in the particular region. And if the disease is happening in farm one or field one, and the neighboring farmers don't have that particular input, they may not be able to help. But whereas in the other region of the particular state, city, or country, you may have the expertise that is there, but they are not reachable in that particular way. So the gap always prevails in terms of the need and the availability. How can all these things be sorted out? Now, the first and foremost thing is a lot more easier to work with is can we actually codify the knowledge that is available with these so-called specialists? So that way, the advantage what we would get is we can ensure the feedback or the inputs are provided are very much upfront and at scale without having to go through a lot of hassles. This is the core item. And in today's world, there are a lot of technologies that are available in order to move in this particular direction. Now, when we are trying to talk about the technology, most of the time, if you look at it, the very initial part that people started was, okay, can I use a basic image and identify the particular things? Because most of the diseases are clearly showcased in how it appears in a particular image or on a screen or a video, things like that. Can we deal with it? Yes, that's easier. What we need is more like a basic collaboration or a communication service wherein I take a picture, I send it to the particular person who's an expert. They would look at it and they would be able to give the feedback. Now, this works quite well. And all we need is a collaboration tool. But then the challenge here is scale is still an issue. What we made is the reach is increased. However, the scale is not increased because if there is one person who can deal with one crop like tomato, another person who can deal with another crop like brinjal, they can all get so many requests, and to parse through, get the answer, give the answer, that becomes a major challenge. So the next step obviously is all these particulars, the inputs like the images, the videos, all those things that are coming in. Is it possible for us to actually do an analysis on that and then give the feedback? And that is where the particular part of image recognition and the ML models related to the image recognition do come in. There are different kinds of models that are there, and we can actually use one of the generic set of models to do the particular activity. But however, the most important point is for all these things, you need a clear set of data which is labeled. what we mean to say is, for the machine or the model to understand which is a particular image where the disease is showcased and which is the one where disease is not present. This is the first and foremost thing that it has to identify, and then it will be able to work. So first we have to give the data in such a format, and then we have to train the algorithm so that based on this data, you can start doing the right kind of a classification. Yes, like you rightly heard, the whole thing is about a classification algorithm. So based on whatever the information that we collected via this collaboration tool, all this data now is annotated or labeled because we have an input for which there is a label that is already given by the expert. So using this, the algorithm is created, and that way the answers are coming fast. But however, here we cannot deploy it right in the field. So the approach in this particular case is train the model, make the model available for doing the analysis, but display all these things to the particular specialist even before we can go to the field. So that way, the model does the actual job of analysis. Then it gives the particular details for a review and approval by the specialist, and it goes through. Now, once the accuracy of certain images are beyond a particular point, then those will not go for review, and that way the scale is coming up well and good. But now also it has a challenge. We are actually saying that there is a disease, but what are all the specific aspects of the disease that the actual sender is not able to understand or analyze? For example, this spot on the leaf or this particular growth on the stem, like that kind of a thing is something that is not clearly visible to the other party or not understood by the other party so that they can act on it. So the next part is, whenever the model does the prediction, it also has to give the particular features which it has identified, which means we can clearly mark a particular segment on the particular image and then send it out. So that way we are saying what is the particular disease, and we are also very clearly stating that this is the very specific feature which is actually evidence for us to say what is the particular disease. This becomes the next part. So that way we moved from automating the disease identification to also providing the evidence for the disease as well. Now, the third part, we know the disease, we know the particular features, which means we also know what is the severity of that particular disease. Is it severity 1, 2, 3, 4, or 5? Now, based on that, these specialists can provide different steps, and internally, we normally look into these particular things. Now that we have identified the disease, we have identified the feature. Based on the feature, we have got the severity. We use these particular things in order to come up with what is the right corrective or the remediation steps that are needed. And that is more like a SOP knowledge base. So we do a lookup and then send the particular detail saying that for the particular image what you provided, this is the identified disease. Here is the evidence in the image that proves that this is the disease. And these are all the steps that you need to follow in order to mitigate your risk. Now, there is a full cycle. However, in theory, it works quite well, but in practicality, there is a major issue. What we are expecting is the image should be of the right quality and it needs to be sent from there. But most of the time in the field where they are taking this images and all, they may not have the actual network availability all the time. So first thing is they take the picture, come to a place where the network is there, upload it, and then the system process sends the feedback. In case the image is of not right quality or the good quality, it says, no, we cannot do anything. We need a better image. So the farmer again has to go take the picture again in a better angle, better direction, and then send it out. So the iterations have reduced, but still it is not completely foolproof. So what is the other alternative? The second alternative is, can we actually do it on the device itself? So what we mean by that is, currently we are sending the image to the server. Server is doing all the things, and instead of that, can we have a lightweight model available to work on the particular device, that is the mobile device itself? Now, when it comes to that, there are 2, 3 issues that are there. First one, a server has a good spec, memory, CPU, and all the things. So we can handle the things in a lot more easier way without any problem. But when we are talking about a mobile device, it has low CPU and low RAM or the storage, all those things. So we have to ensure that we are able to address it in a slightly different way. So first and foremost, can we actually do the particular change of the model or the algorithm itself? Yes, it is done. We have reduced, but still it is not good enough. So what we do is we actually go ahead, split the entire thing into different segments. Like for example, you have crop one, crop two. For example, crop one is tomato, crop two is capsicum, crop three is cauliflower, like that. You have different of these particular crops that you are trying to work with. So a farmer can say which are all the crops that is of interest, and then behind the scenes, the server has individual models for each of these crops. So that way you have not only reduced the model size, you have also reduced the weight size by actually splitting or segmenting the entire set of crops into individual crops. So whichever farmer is interested in the crops like A, B, C, they will select on the application saying that these are all the crops that are needed. And during that particular selection, where the network is mandatory at that time, all these different models, weights gets downloaded onto the particular mobile device or the mobile application itself. Then onwards, everything is pretty much straightforward, which means they can take the device to the field, they can do the photo check and all. So you will get an immediate feedback saying that the photo angle is not right, turn left, turn right, zoom in more, or put a light. All those things are there. And as they do it, immediately the system will understand what is the device and will give the answers immediately. So that way it is easier. And once a while, they will have to update it, because obviously, as you know, ML algorithm is not like a foolproof in terms of one iteration. There are, for example, it might be accurate till 90%. Then with the next set of training, it may go from 90 to 92, 94, 96, like that. So we will have to ensure that once a while, we sync up the particular device with the server and then get the newer set of heights, which is the retrained one with better accuracy. So that way, the system will start giving better advices and better things. That is one of the most important part. Now, this is all good, but then there are other challenges that will start surfacing. First one, now when we are talking about the particular crop and the kind of remediation, then the availability of certain ingredients or certain medicines on the particular providers and all, most of them are local changed. Like for example, what is available in a state like Karnataka, Andhra Pradesh may not be available in Haryana, Punjab, because the providers or the sources are completely different. So depending on the particular locale or the geography, we can also customize these recommendations as to what needs to be done, how it needs to be done, all those kind of scenarios. That becomes another part. So that way we are moving from identification to local identification, providing the remediation, and also personalizing the remediation steps as per the specific locale and the crop itself. So that is the kind of evolution that we are talking about. Now comes other things. Like for example, when we are talking about the newer breeds that are coming into picture, there the variations will be there. So every time a newer strain of the disease or a newer breed of the crop comes into picture, the way the features are reflected will undergo a change as well. So we need to work with the different organizations which are introducing new breeds into the field, and we have to work with some of the agencies to understand that which are all the new strains of diseases they are identifying in specific locale. And based on that, we need to start working. For example, a new strain is identified in one of the region of Tamil Nadu and it is not available anywhere else. So you have to ensure that you have access to those particular agricultural institutions out over there, which can provide those details. So you also have to create a good network as and a platform as well, so that the different set of inputs will start flowing in via these organizations into the particular platform, which is used for more training and then the deployment purposes kind of a thing. That's another important thing, to keep the system always up to date and then support the teams in the right way. Now comes the other part. There are few particular diseases which are very different in nature. For example, we are talking about a stem borer, let's say. Now, most of the time when you are taking that, let's say, for example, you are looking at something like coffee plant. The stem is underneath and it is not even visible to you. So if there is a borer out over there, for you to actually take a snapshot of that one by doing the pruning and all is definitely a bit tough. And that is where the other kind of challenges will start coming in. So now, what is the other alternate way? Can we look at some of the foliages? Can we look at some of the external atmospherical or the ambience factors? And then based on that, can we do it? That was the first step wherein we started looking at additional things. It's not about specific features. It's also about what is the normal and what is the anomaly. Because a device is identified by a feature, but instead of that, if we say that there is a particular disease feature, there is a normal feature, and in between there can be any anomaly, which means no disease is also identified, neither is it a normal. So what is the gap there? That is what we are looking at as anomaly. And with that particular anomaly and the surrounding factors, what we spoke about, it's easy for us to go to the next level and do identification. But however, the accuracy there is not so great because of reasons, as you can understand, because we are looking at only the external factors, but what we need is a next level of flow factors. Now, in that particular scenario, what else can be done? So, two, three things. First one, with the advancement in the particular technologies, we can apply different kind of filters on the image that you have taken, which means I can take an image, apply a filter to say how this particular leaf or the foliage will look in an infrared light. Now, that is a big advantage because now you are looking at the system and you are getting the information that is not visible to the normal eyes. So, with that kind of a scenario, it's possible for us to work and make sure that the things are in a better position. What we mean by that is, if something is deep red, then there is a lot of heat out over there. And as the gradient moves towards the blue, which means it's a normal condition or a kind of a cold or a frigid condition kind of a scenario. This variation actually helps understand normally when a plant is healthy, these are all the kind of different colors or gradients that we see. In case of any anomaly, we start realizing that the gradient is different, which may not be visible to a common eye, but from the perspective of how the IR filter is working, we would be able to deal with it and provide the right kind of information. This actually helps identify the things even before the things go for a toss. For example, in case of a stem borer, we can see that some of the hairs in the particular foliage are actually turning slightly black. That kind of a thing immediately helps us that, okay, so now we know there is a particular problem because we are seeing those kind of specific symptoms even before the features are available. So that is what helps us further improve and then give the things in the right way. Okay. Further, as we move along in the same line, there is also additional things that are coming in now. For example, we are good with the features of the plant itself, but how about the features of the soil and the surrounding things? For example, the soil may have higher acidity content. Some of these things are more visible, but some of them are not visible. Similarly, the granularity of the soil and other things, that's also is something that may have a. So how can we find out that and then try to see that which are all the diseases that may hit because of these particular reasons? Again, the advantage what we got is in terms of the better image recognition models. And also in this particular case, even before going to the image recognition models, there are a lot of additional uh, models or algorithms that have come in, which would help us make the things better. For example, if you give a photo, in that there might be a plant, there might be soil, there might be some surroundings. Now, depending on what we are trying to do, there are segmentation models which come in, which can cut off all the unwanted things, and it can very clearly show that, hey, you are interested only in the particular soil. Now, in this image, I have done a cleanup, and here is the patch of the soil that is available. The next thing is we pass it to the enhancement models, which can look at that and then try to enhance the quality and ensure that the further classifications are done in the right way. So once the enhancement is done, then it goes via a set of classifiers to say what kind of anomalies or what kind of features are you seeing in the particular soil. Then based on that, you will be able to add a additional set of information, more like enriching the data for prediction. That by itself is not the prediction, but it is giving additional data which can improve your prediction. So that is one particular part. Second thing is, when we have these kind of additional enrichments or features that are coming into picture, each of them may need to have different weightage. Because, for example, we can say that the particular foliage is good, but however, the soil is having some kind of issue, or vice versa. So, depending on all these things, we start giving a weighted average, which means we create an ensemble model, is what we call it, which means you have different models giving information from different sites, like the model on the leaf that will give one particular recommendation or classification. The next model is it will do a application of IR or the infrared filter. It will give one more classification or recommendation. Similarly, you go to the soil part, it can give one more classification. The ambience and the other features, it can give one more. So you take all of them and you have a master model which will use all these things as inputs, and then it will use the right kind of weightage against each of these outputs from the individual models, and it give a final output which is with a better accuracy and which is collating the information across the board. So that way it can override, it can converge and do all the things that is there. So that way now, if you look at it, whatever the individuals who have been doing this, the same concept is now available in terms of the models doing the same activity. And at the same time, you are able to do all these runs locally on your device in your environment without a reliance on any of the external items like internet, bandwidth, none of those particular things. And the third one is you are able to get very personalized remediation steps specific to the crop, to the disease, and the particular locale. So that way, everybody is able to get the results or the particular reports within real time, within their particular reach without any particular problem. And the main thing is data. As you can see, it's more about how the data is made available from various sources onto the platform and how the technology has evolved in order to create these models out of the data. And the most important part is the kind of pipelines, what is being built with the objective in mind. Like you have X number of stages, each doing a particular task, giving the output, and you have a mesh which is actually reading the output from all these particular pipelines and then going ahead and creating the final outcome in a very specific way. Some of the teams may be really interested to know what exactly are the kind of algorithms. So in this particular case, as you can understand, the algorithms are evolving day by day, but some of the most commonly used ones that are there are neural networks, because they are one of the base reasoning or the base set of unsupervised learning models, and they can look at various set of data and then come up with a clear way of identifying a pattern without much of a hassle. But the need of the data, high amount of data is there, and then based on that, it can do the job in a very efficient format. So these models are the ones that are there. The second thing is, like what I mentioned, all these neural network models that we are talking about are always of a slightly heavier size because they have lots of layers, they have lots of neurons or perceptrons that are there and all. So what we will have to do is we need to ensure that all these particular things are actually pruned to say that these are all some unwanted layers. So we better remove and still make it accurate or optimal. That's one. Second thing is, can we also look at giving a weightage on certain features so that the size of the parameters get reduced? In essence, it will also come up with a lower footprint. And then the third one is converting it into a different format so that it is made portable and is available for the mobile devices to download and work in an efficient format. So these are all the particular things that we will have to do against each of these particular models so that it can work in a nice way. Apart from all this, one other thing which is not related to ML or the AI, but definitely a problem with the distribution is what I would like to also bring up. So as you know, in our country, there are different kinds, or not just in our country, any other country also, there are a lot of different makes, models, OS of the particular devices. For example, people may say that, hey, I'm using Android, so and so version, and your app is not working out over there. But the other person may say that for me it is working fine. The third person may say that, hey, I'm using a completely different OS, which is iPhone, and I need to work on that as well. So like that, if you are trying to look at it, the distribution again will become a problem because the models will run the same way, but the shell, which is the app, that has to be completely different. So the best way to deal with it is use some of the particular cross or a hybrid platforms, which means you create the code in a more general language and then you use the same code to be compiled for different targets parallelly, which means I have only one program that is written, but while building the actual executable, I can give different targets saying that I need this for the Android version X. I need this for the Android version B. And I need this for the iOS different version. And I need this for the Kia OS. Like that, we can give all the different possible target combinations as well as the OS version combinations so that it can do the target build. And now, depending on which is the particular OS and which is the particular version of the OS that is being used, we can download and make it work in a lot more easier format. So that way, the distribution is also something that is addressed by using the cross-platform technologies that are available in the market currently. Now, with this, what we are talking about is the actual objective of the need and the journey altogether, starting from how you start with a very basic or the minimal model of collaboration, then moving towards the scale in terms of model with a review approval, then a autonomous model, then addressing the bandwidth and moving towards a edge-based deployment, and then from there further enhancing the features to cover all the other aspects, and from there further into the distribution channel of how different channels, OSS, and all the other things can be dealt with. Apart from all this, the most important point, like what we said, is the relearning or the retraining to improve the accuracy. Now that all these things are available on the field itself, a lot of the teams can easily take the picture. And in case if something is going wrong, they can say, this is a problem, the system is not working as expected, and report it. All those reports are collected back as a feedback and they are used for further analysis by the experts to say whether it is right or wrong. And then based on that particular labeling, the retraining happens, and obviously the farmers get to download the newer version of the model with better accuracy. So this is the journey that we are talking about. I would like to understand if there are any specific questions or any specific items so that we can continue on the subsequent parts.
Okay, thank you very much, sir, for your wonderful talk. I'll take up the questions now. The first question is, sir, what types of crops can currently be detected using your technology?
We have multiple of them, but the most trending ones are the things like tomato, maize, uh, pepper, chili, brinjal. Those are the things. We support around 30 plus kind of crops of the locality. Not the exotic varieties, but most of the general varieties. Again, like what I said, most of the trending are these 4, 5.
Okay. How accurate is the disease detection system under real field conditions?
Okay. See, it will not be 100% accurate because we have to understand that to move the needle from 0 to 80 may be very fast, 80 to 90 would be slow. Further beyond that, it would slow down. And when we want 100% accuracy, it defeats the purpose. I mean, there won't be a ROI. So what we normally do is before we go to the field, we ensure that internally we do the right kind of testing in the particular field conditions and ensure that always we are going beyond the 95%. The 5% will improve over a period of time. And so far, what we have seen is the best is around 98.5% reach. I hope it will further improve, but currently our range in the field is between 95 to 98.5.
Okay. Can this technology detect diseases at an early stage before visible symptoms become severe?
Yes. If you remember, we spoke about the IR filter kind of a scenario, right? So there, actually, we are not looking at the symptoms that are visible. We are looking at the symptoms that are not visible also and available in a different spectrum. So that way, we are able to understand and then work on it even before the issue happens. Like for example, there are certain diseases which actually blocks the pores. But now we are unable to identify from an external purpose. I mean, via our normal eyes. But what we are able to do is, because we are using this filter, we know that, hey, even though there is a water supply on these areas, we are seeing that in the leaf, the particular cells are dying down because of the IR part, which means it is turning blue and the black kind of a scenario. So immediately we can go back and say, hey, there is a problem here. It is not still visible, but it is there. So that way we are able to identify it in a better shape. So now from a model perspective, when you are talking about, you have three different things. First one, the set of features that are visible, the set of features that are not visible, and a prediction based on these two features, saying that based on whatever we are seeing, we can predict very likely that this is going to be the scenario in the next few days. And hence, it is better to take a preventive action rather than a corrective action. So we are moving from the reactive towards a proactive. So from the system perspective, this is certainly possible.
Okay. Can farmers use the technology through a smartphone or is it specialized equipment required?
No, they can use it on any of their smartphones. All we need is internet connectivity so that you can connect and download it. Once you download, you have to register using the phone number, and then you can select the different crops that are needed. The initial download of the models will take some time. And once that is done, I mean, when I say some time, depending on the bandwidth, if you are in a 3G kind of a scenario, it will take around 10 to 15 minutes. And after that, everything is offline, so they can use it without any problem. There is no specialized equipment that is needed. Everything is happening on a normal mobile device like Android or iOS.
Okay. How quickly does the system provide disease diagnosis after an image is captured?
Since we have done the changes now, see in the earlier scenario, it used to take time, but now we have done the changes and everything is working on the edge, that is on the device itself. So it's hardly in a matter of few milliseconds.
Okay.
The
Does
moment
the
you
system?
are
Yes, sir. Yes, sir. Tell me, sir. Please
The
finish it.
moment you open a camera, now you don't have to even take a image. We are relying on the video itself. So you can open the camera in the video mode. It will start recording and it will immediately show on the screen itself saying that, hey, these are all the features what you are seeing. So all those dotted lines or the round marks, all those things, it will get highlighted and you will see a particular disease name also. Next to the disease name, you can click and go to a different screen where all the remediation steps are there. So it is almost near real time on the field.
So the system also recommends suitable control measures after detecting the diseases.
That's right.
Okay. Can this technology reduce unnecessary pesticide spraying and input costs?
Definitely, yes. The things what we have done here is like what you asked earlier, it's about identifying before the actual symptoms are visualized, which means you are identifying it when it is even severity zero or that kind of a thing, right? So the moment you are able to identify it, then as a part of that, you have to take only preventive steps, not the corrective steps. So the preventive steps always need lesser amount of other particular pesticides and all. That is one. Second thing also is we do have some of the recommendations that are there from some specific organizations, accredited organizations, which talk about what are the other alternate ways to also deal with it. So both of them are available. And because of that, like what you rightly mentioned, the reliance of the pesticides is reduced, and which means actually the particular crop that we are going to get, that is more or less pesticide free.
I'll move to the next question, sir. So what are the biggest challenges in developing ML model for Indian agriculture?
Yeah, this is a right question, and this is what actually is one of the most challenging things for us also to develop. See, the main thing is the kind of varieties that are available for the same crop, and the particular kind of ambience or the climatic factors that are affecting the particular area. Now, as you know, India is a peninsula. So you have the range, that is like you have the best snow-capped mountains to the desert to the arid regions to the deltas, belts, all those kind of things. And the same crop, like if you're taking one rice as a crop, you're seeing how many varieties of there. You can see Nellore, you can see Sona Masuri, you can see Mysore, so many different things, right? So these variations are very, very important because these variations actually have different impact. Like the same disease, how it will appear in one case versus the other case, depending on region one versus region two, because of the climatic conditions and other things, it is very, very different. And it also poses a very important challenge. So collection of the data in all these variations, that is one of the huge challenges. Second thing is once we have this data, labeling them is also important because most of the time people recognize it based on the nearby region, not the other ones which are from a far region. Those particular features are not seen in this region. So there is a gap there. So we have to rely on the local specialists or the specialists in the specific region to help us do the annotation. And once these two are done, then we can go ahead and then do the actual training. So collection, annotation, verification. These are all the three important pieces that is of challenge out over there. But once we have that, because of the network or the platform, then the rest of the things is a lot more easier. It's not the model that's a problem, but it's the data availability that's a problem.
Okay. How do varying weather conditions, lighting, and image quality affect detection accuracy?
Yeah, this is also a very valid point. In the initial part where they had to send the image to the server, at that time this was really important because if they don't take with the right quality, this one and all, it becomes a problem. But now that everything is working on the edge, so the first and foremost thing what we do is if we say that the particular camera quality is not good, it is not with the right zoom level, or the lighting conditions are not there and all, we can automatically prompt it to the user then and there itself saying that can you enable the light, can you change the zoom level, all those things, so that we will be able to get the accurate picture then and there.
Okay. Sir, what advice would you give to farmers to capture good quality image for accurate analysis?
Uh, so in this particular scenario, it is hard to say what is a general rule because which kind of a crop, what is the disease, which is the location, what is the time of the day, which is the area, all these things matter. And hence what we have done, like what I mentioned earlier, what we have done is in the particular app itself we have created certain guidelines. So every image that is getting captured or every video that is getting recorded, it goes through that particular guideline checks, and if any failure is there, we automatically raise it so that the things can be handled. So rather than saying that one static guideline is there, depending on the current transaction, whatever is the gap, it identifies that and ensures that the farmer takes the corrective action at that particular point.
Okay. Do you see artificial intelligence and machine learning becoming a standard tool for every farmer in the coming years?
Definitely, yes. The ML model, like what we said today, it is already on the edge and it is able to work. But unfortunately, AI part, that is the LLMs, they are not really so smaller that they can be run on the edge devices. There are few models that can be run on the edge device, but from a accuracy, usability perspective, they are not up to the mark in the field. So uh, there is a gap with respect to ML and AI currently, but that gap is narrowing very, very fast, is what I would say. And now, even when you are trying to look at the specific part, like the remediation, depending on the severity and all, earlier we used to say that for each disease, each region, each severity, you need to have a different steps. But what we have changed is we have got our own custom model that is developed so that it can personalize and give it, which means you have one uh, remediation procedure in which we have clearly marked saying that follow this step in case of so and so and all. So the moment the severity and the other things are identified, internally the model takes the particular remediation procedure. Depending on the identified features, it further personalizes that particular thing by removing certain steps or modifying some steps with specific quantification, and then it presents it. So that way you have a combination of both ML as well as AI. ML is more deterministic, and to ensure that a disease is properly detected and all, there it would be very helpful. But to give a feedback and then ensure that the teams are getting the right kind of information, there the other model will work. To also explain a bit more in detail, we have all the things that are available to us in English that we have stored. However, as you know, all the farmers would need a particular answer in the local language, like it may be Kannada, English, Hindi, whatever the appropriate language that they are speaking. So we cannot store all the different languages because in India itself we have 26 plus languages. So all the languages within the particular phone, because that space and the cost, all those things are going to be higher. So what we have done is we have used the translation service. If you look at the models in your Android phone or the iOS, they can do a offline translation. So we rely on those particular things. And then if a person says that the preference is to get it in Kannada, so the model gives the personalization in English, which goes to this translation API of the device, and it gives the final answer for in the display to the farmer in the local language, that is Kannada.
Okay. Can farmer producer organizations and agri input dealers use your platform to support multiple farmers?
Oh, definitely, yes. There have been few cases where some of the organizations have taken this and they said they want to support a set of farmers and they would like to distribute it for the farmers directly via their organization. So definitely that is possible. Like if you're talking about a cooperative society or you're talking about contract farming, wherein one organization is working with multiple farmers and all, definitely that is possible.
Okay. Is your solution affordable for small and marginal farmers?
Uh, the answer is depends on which is the channel that you are trying to look at. See, at any given point of time, if you are looking at for many of these former services, there are most of the organizations which are NGOs that are trying to deploy it. There are other commercial things like the APMC and all because they rely on the farmers, they kind of fund it. The third one is private organizations which are doing a heavy or a contract farm kind of a scenario. So from via one of these channels, obviously it is very lot more easier. But if we are trying to talk about a scenario of B2C instead of B2B2C, yes, then the challenges may arise. But however, with the way the current organizations, the steps by the government and all, there is a higher chance that the end farmers may be able to directly work with us.
Okay. Are there opportunities for startups or agri-businesses to collaborate with the Arnetta technologies?
Definitely, yes. And we have been doing some level of collaborations both with organizations and the other dairy and those kind of scenarios. So definitely we are open for that.
Okay. Okay, thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we would like to thank Mr. Aravinda for the talk and for answering the questions. This meeting will now be closed.
Thank you. Thanks a lot.
Welcome, sir.
Have a nice day. Bye.
Bye-bye.